Example number 4. This one's probably going to be the most challenging one, I guess, thus far, because of the algebra involved. Let's go ahead and take a look at it. This will also be our final example for section 12.3, for chapter 12, and for the entire course. So I hope you enjoy. Here we go. First move. Figure out the first partial with respect to x. That will be 3x squared. Ooh, we do differentiate this. We hold the other two as constants, so we would get minus 9y. The constant portion remains. This in its entirety is a constant, as is this, so the derivative of each would be 0. The next first partial with respect to y, that's a constant, so it's 0. This one, you keep these exactly the same. They are unchanged. That's the constant multiple rule, but you do differentiate y. The derivative of y is 1. So you get negative 9x as the derivative of this term with respect to y. The derivative of the next term with respect to y is plus what? Plus 3y squared, and then the derivative of a constant is just 0. Well, this looks fun. So what this is going to do for us is generate a system of second-degree equations. So I'm going to go ahead and rewrite this as 3y squared minus 9x equaling 0. Okay, well now what the heck do we do? Well, let's go ahead and just do this. Let's not waste any time. Let's just try to isolate one of our variables. I'm going to go ahead and isolate y. So in this first equation, what I'm going to do, I'll rewrite it for you. In this first equation, I'm going to isolate y. I'm going to solve for y. So I get this. Dividing both sides by negative 9 would yield what? Y equaling 1/3 x squared. So now I have y equaling this value in terms of x. Okay, so what I'm going to do is I'm going to replace this y right here with what y must be equal to in terms of x. So let's use substitution now and work that out. So in other words, 3 times whatever y is, which is 1/3 x squared, and then you square it. This entire thing is y. Because y is being squared, you square this entire quantity. All right, then let's work out the rest. Minus 9x, or write down the rest, I should say. Minus 9x equals 0. All right, let's solve this equation then for x. So let's square this term. We would get 3 times what? 1/9 x to the 4th. And then write down the rest. Okay, so at this time, I'm going to do a couple things. So here we go. I'm going to factor out an x. I'm trying to solve this thing for x. So I'm going to factor out an x. And then what am I left with? Well, let's go ahead and simplify this. 1/3. And then you have x to the 3rd power minus 9. Remember, I factored out an x. All right. So now what we have here really are two factors that equal to 0. So now we know x is equal to 0, or what? 1/3 x cubed minus 9 also is equal to 0. So when you solve this thing, you would add 9 to both sides. You would add 9 to both sides. Then you'd multiply both sides by 3. And that would give you x cubed equals 27. X cubed equals 27 would generate x being equal to 3. All right, so what are the critical points here? Well, let's figure them out. We would have critical points where then? One where x is 0 and a second where x is 3. Okay, so when x is equal to 0, we have to determine the corresponding y value. The easiest way to do that is to use this. Beep, right there. So if x is 0, plug it in, you get 0 for y. If x is what? If x is 3, well, if x is 3, what do you get? 3 squared is 9. 1/3 of 9 is 3. So these are your two critical points. At this time, you would go through the motions just like we've been going through. But this is probably the hardest part. Let's go ahead and finish this up. All right. So we get f sub xx, second partials with respect to x would be what? Look at this. That would generate a 6x. Okay. The second partial with respect to y, that'd be giving us a 0. This will be generating a 6y. And now the first with respect to x, second with respect to y would be equal to what? Well, look at this one. What's the derivative of the first term? With respect to y, the derivative here is 0. What's the derivative of this term with respect to y? Good, it's -9. All right, so now we have all the pieces of our puzzle here. Let's go ahead and put that puzzle together. All right, so let's first look at our discriminant value at 0, 0. So let me write out the notation. Times this. Isn't this is a blast, isn't it? You should not be bored working on this stuff. That's for certain. It's exciting. All right, so there is our discriminant written out for our critical point 0, 0. So what do we get here? Well, look at our values that we obtained earlier. So our second partial with respect to x, 6x. If you replace this x with this 0, you'd get 6 times 0, which is 0. Moving on. If you replace this y with this 0, you get 6 times 0, which is 0. Finally, be careful here. The first partial, then second partial of this critical point squared would be -9 quantity squared, which is 81. Again, first partial with respect to x, then second with respect to y of this critical point would generate a -9, and then you square it, so you'd have an 81. So this is going to be equal to a -81. All right, we go and look at our information. If our discriminant, our value that we obtained from the second partials test, if it is less than 0, which it is, we now know we have a saddle point. Okay, so therefore, saddle point at what? At where? F of zero, which is going to be based upon you plugging in 0 into every x and into every y, and you'd obtain a -2. All right, so there's your order triple. 0, 0, -2. Okay? Moving right along. Remember, we have our second critical point here. Was at 3, 3. So let's go ahead and work that out. 3, 3. 3, 3. And finally, one more. 3, 3. All right. So, let's see if we can do this. Okay, so what do we need here? We need the second partial information. All right, so I'll tell you what, let me go ahead and fold this back here, give myself some more room. Yoink. Okay. All right, so let's go ahead and rock and roll. We have what then? With respect to this critical point now, our second partial of x, 6 times 3. 6 times 3 is what? 18. Okay, with respect to this one, you're going to replace this y value with this y value. So 6 times 3 is 18. All right, minus what? Well, this, regardless of the critical point, is a constant. It's -9. So it's always, because it's a constant in this particular case, going to be -9 squared. All right, so what do we get? Well, I don't know. What do you guys think? 18 times 18 minus what? Minus 81? I think that's 243, I think. All right. It is well greater than 0. So because it's well greater than 0, it's going to either be 1 or 2. It's either going to be a relative minimum or a relative maximum. Okay? Let's see which one it is by running another test, the second partial with respect to x, okay, of what? Of this critical point. And so what does this equal? Well, it's going to be what? 6 times the x value here, okay? 6 times 3, or 18. Now, is 18 greater than or less than 0? It's greater than. Okay, so what does that mean? Well, because it's greater than, you have a minimum, all right? The same thing still applies for this test, if I haven't shared that with you yet. And I know for a fact I haven't shared that with you yet because I'm the one running this show and recording these notes. Guys, if this second partial test is positive, you can go back and think of this. If it's positive, you're going to get a minimum. Versus if it were negative, you're going to get a sad face, which is going to be a maximum. Okay? That's true for this portion of the second partials test only. All right? Okay, anywho, this tells us what again? That you now know for a fact that you have a relative, what? You have a relative minimum where? At f of 3, 3 equaling what? Well, you have to be able to plug in this x value and this y value where? Into your original function. Into your original function, right here. Every x is a 3, every y is a 3. If you do that correctly, you should get this minimum value. Negative 29 is actually the relative minimum. Okay? I hope this helps. I'm sure it's a blast. Hope you're staying healthy. And hopefully I'll see you again real soon.